value and the true value. Let's say the true value is t, and true let's see true and individual is x. True value, individual value, true individual. So this t and this is x. So the difference between the individual value and the true value is known as an error. All right. So we take errors. Let's say we have a set of data like we did before, 10.0. Let me limit it this time to 10.3. All right. And the true value is 10.1. Don't take the true value, the error, 10.0 minus 10.1. You know it's 0.01. That's the error. All right. That's the error. You can also do this for other data. Okay. So you notice that I didn't put sign at the back of the 0.01. Okay. We put sign if it's absolute, an absolute error. Okay. The errors. Let's say we have. Okay. Let's talk about the absolute error. So, you know, the errors are differences between the individual value and its true value. Okay. Absolute error. Absolute error signified as this: absolute error. Okay, so it's the same thing. Difference between the measured value and the true value with respect to sign. All right, we put sign before the value. The difference between the individual value and the measured and the true value with respect to sign. Okay, we put signs before them, plus or minus. Let's see, we have 0.01 like before. So it can either be plus 0.01 or minus 0.01. Okay, 10.0 minus 10.1. So here we have 0.01 minus 0.01. Okay, but if we have 10.2 minus 10.1, we have 0.01. We have plus. Right? So you can either put plus or minus 0.01. So the error here is plus or minus 0.01. Okay. So the formula is like this. Let me say, give it this way. Formula is so absolute error is minus t, or you can take the mean, or let's see equation 1 x bar minus t. You can take the mean and then subtract the true value from it, okay, to make your work easier. So you don't have to do for each of the values you are given. Okay, we'll talk about relative error, relative accuracy, relative error, relative accuracy. So relative error is the absolute error over the true value. Relative error is the absolute error. The value go for the absolute error. Don't forget that the absolute error is x minus t, or x bar minus t. Don't take the mean. Okay, mean. Okay, that's the relative error. And relative accuracy is now remember we talked about accuracy. Okay, the closeness of individual measurements to the true value. All right, so you can think about it and say, okay, relative accuracy will be x over t. All right, x over t or x bar over t. Remember we mentioned that relative accuracy can also be the closeness of the mean to the true value. Alright, closeness of the mean to the true value. Okay, so now we go forward to rules of combination of errors. Okay, the rules of combination of errors. Rules of combination of errors. Okay, rules of combination. Another rules of combination of errors, you have maximum errors and standard errors. Alright, but maximum errors combine differently. Different rules to standard errors. Okay, so they don't have the same rules of combination. But before we go into rules of combination of errors, let's do the significant figures and rounding off. So by the time we start little calculations, we'll be sure to do well. Now let's look at significant figures. Significant figures. Significant figures. Okay, let me see. Significant figures. Significant figures. Okay. Now significant figures talks about the precision of a measured quantity. Alright, the precision of a measured quantity. Alright, precision of a measured. What's we always said that precision is the closeness of replicate measurements to each other. Alright, so we have different measurements: 2.1, 2.2, 2.3. Those are close, they are precise. But when you have 2.1, 2.5, 3.0, those are not precise. Right? And we also have the rules of that govern significant figures. Let me just give you these rules so you flow along with me when we start working on them. Okay, all digits are significant except zeros at the beginning of the number. All digits are significant except zeros at the beginning of the number. All digits. Now we have them 0, 9, 1, 2. Now this is insignificant, right? Is insignificant. So remember that rule number 1: all zeros are significant except zeros at the beginning of the number. We have 0.912. We have 0912. We have 0.00912. Okay, and we have 9.12. Okay, okay. Now let's see how many significant figures we have here. We have 3 significant figures. We have 3. Here we have 3, and we have 3. Since there are no zeros here, 3 zeros. Remember the rule: all digits are significant except zeros at the beginning of the number. And this one also, we have 3, right? Okay, we have 3 also. So this have 3 significant figures: 912, 912, 912, and 9.12. Because these zeros are before the numbers, alright? So they are insignificant. Even this one, these three of them, they are highly insignificant. Okay. So we have so let's go to rule number 2. The zeros between non-zero digits are significant. Zeros between non-zero digits are significant. Now you can't possibly say 606 and say 0 is insignificant. No. 0 here is very, very significant. Alright, 606. 0 is very, very significant. Okay, yeah, significance. SGF, significance. Okay, and also we have, I'm gonna give you another example. 60.007. Remember the rule? Zeros between non-zero digits are significant. So you say 6.007. The zeros here are significant. Alright. Remember rule number 1: zeros, all digits are significant except zeros at the beginning of the number. Remember that rule, and you sure not to make a mistake when doing calculations. And okay, and the rule number 2: zeros between non-zero digits are significant. Zeros between non-zero digits are significant. And we have 5 rules, so let me go to rule number 3. Rule number 3 is very interesting, right? Chemistry is very, very interesting. Okay, and you get to love chemistry when you go higher. Okay. Rule number 3: terminal zeros ending at the right of the decimal point are significant. Terminal zeros ending at the right of the decimal points are significant. Okay, let me give you an example so you understand what I'm saying. Terminal zeros. Someone remind me the rule again. Okay. Terminal zeros ending at the right of the decimal points are significant. So 90.0. Okay. 90.0, 9.10, and 9.00. Okay. So this, we have 3 numbers, 3 figures. So rule number 1, following rule number 1, you know that zeros, all digits are significant except zeros at the beginning of the number. This 0 is not at the beginning, neither is this, and neither are these. Okay, so this rule says that zeros, terminal zeros ending at the right of the decimal points are significant. Terminal zeros ending at the right of the decimal points are significant. So these are significant. Alright, so you get to understand this when we do exponential work like this. Alright, let's see, 9.0 times multiply 10 to the power 3. We have 9.00 10 to the power 3. This has 2 significant figures and 3 significant figures. Alright, be sure not to make that mistake. Okay, these have different significant figures, even if they are basically the same thing, but they have different significant figures. But you understand more when you go to rounding up from calculations involving significant figures. Okay, so that's rule number 3. Rule number 4. Now, rule number 3: terminal zeros ending at the right of the decimal points are significant. Alright. But rule number 4 says terminal zeros ending to the left of the decimal point may or may not be significant. Terminal zeros ending at the left, ending to the left of the decimal point may or may not be significant. Okay. Okay, remember rule number, what was that rule? Number 2. Rule number 3, this rule, okay. Rule 3. Now it says that terminal 0 to the left of the decimal point may or may not be significant. Now it varies. Now, let me give you an example. 0.0054 002. Okay, now this ends to the left. Okay, it ends to the left, going this way, this to the left, this to the right. Alright, but remember rule number 2, zeros between non-zero digits are significant. Zeros between non-zero digits are significant. So these are non-zero digits, these are non-zero digits. So zeros here are significant. So here we have 6 significant figures, and we have 3. We have we have 2 significant figures. You have 2 significant figures. So now remember these rules, they intertwine. You have to know one rule so not to miss the other rule. Alright, from top, all digits are significant except zeros at the beginning of the number. Alright, possibly terminal zeros. Okay. Rule number 2, zeros between non-zero digits are significant. So this rule applies here. It applies here. It applies here. Yeah. It applies here. Rule 2 applies. Okay. Terminal zeros ending to the right of the signal figures are significant. So rule 3 also applies here. Rule 3 also applies here. Okay. Now this one, rule 1 applies. Rule 1 applies here. Rule 1 applies. Yeah. Okay. All these are significant except zeros at the beginning of the number. So rule 1 applies here, rule 2 applies here. What was rule 2 again? Rule 2 is zeros between non-zero digits are significant. Rule 3 says terminal zeros ending at the right of the decimal points are significant. Remember rule 3? Okay. So you can also say rule 4 is the combination of rule 2, rule 1, and rule 3. Alright, this is rule 4. Rule 4. Remember rule 4? Terminal zeros ending to the left of the decimal point may or may not be significant. Alright, so this ends to the left, this ends to the left, this goes to the left, but these zeros are between non-zero digits, so they are significant. Alright, they are significant. Just like saying you have 2. Okay, you have 6 significant figures here. Alright, so that's that for rule 3 and rule 4. So we have the last rule. We have rule 5.